So far, we've looked at several conic sections. We've looked at ellipses and hyperbolas. We want to look at the last one in this little video right here, and it's parabolas. I would point out, all of you have graphed parabolas before. You did it in 171. Don't forget all the graphing you know. In theory, a lot of these parabola problems can be solved out using the information you already know from 171. There's just a little bit more terminology that we're going to need when we set these problems up. But as far as the definition goes, for a parabola, the actual definition is the set of all points whose distance from a point called the focus and a line called the directrix is equal. So essentially the idea, if we want to look at a regular graph right here, say I put my focus right here at the point 0, 2. Then I'm going to say my directrix is right down here. We'll call it this line right here. Y equals -2. The parabola is all the points a fixed distance from there. So essentially, we start with this point right here because that's a distance 2, and this is a distance 2. So this point becomes the main point that I care about. You guys already know what it is. It's the vertex from graphing parabolas before. But now, we all know what a parabola looks like. So it looks something like that. And essentially the idea is, if you found the distance from, say, this point over to the focus and down to the directrix, those should be equal. It doesn't look like it on the picture. My parabola should be a little bit flatter. But essentially, the distance from here to here and here to here is the exact same. That's what makes a parabola. As far as it goes, again, you guys already know how to find a vertex. You already know how to tell if it opens up or down. So we're going to focus more on being able to find this focus right here and that directrix right there. And there is one difference. For the most part, up to this point, when you're graphing a parabola, you see something like y equals ax squared. You know it's a quadratic, you know it's a parabola. That one's centered at the origin. It opens upwards if a is greater than 0. It opens downwards if a is less than 0. And that's kind of how we see them. If you want to move it around, you can do something like y plus k equals a times x minus h squared. And now I just took my parabola and I shifted the vertex around. You guys know all your transformations. If I want, I can bring the k over and get y equals a times x minus a squared minus k. And now I can see my transformation for x, my transformation for k. I'm done. I can find my vertex, make it go up or down, whatever I want. The problem is, that's not actually how we write them when we're looking for the focus and the directrix. It's the same equation, but it looks different. And how we actually want to write them now is in terms of, since it's a parabola, in terms of the square. So maybe x squared equals 4py. I'll explain what the p is in a minute. But essentially, you're used to solving your equation for y, like we had over here, and you have y equals something times x squared. Now we're going to solve them for the square and put the y with all the other stuff over on the other side. But essentially, it's no different. This is still a quadratic like we used to. If you wanted, you could solve for y, and you would get y equals x squared over 4p. And that's just a parabola centered at the origin. If p is greater than 0, it opens up. If p is less than 0, it opens down. So there's nothing new here. It just looks different. But the way it works is, suppose we go back to my parabola right here centered at the origin. vertex right there. And I pick this point right here. I'll say my focus is right here. And my directrix is right down here. The P in that equation is the distance from the vertex to the focus, or from the vertex to the directrix, which just allows me to label these points right here. So ultimately, when we're looking at a parabola, we need to be able to find my P, because once I can find the P, then I can find the distance to the focus and the directrix. And as long as I know where my vertex is, then I can tell where these points are and I can get my graph done. So let's see. For the sake of argument, suppose we have, let's see, x squared equals 2y. I want to find P. Well, we can just equate these things. I have my equation solved for x squared, so whatever the coefficient of y is equal to 4p. So I just set it up. 4p equals 2. P equals 2 over 4, which is 1/2. So then, to graph this parabola, my vertex is at 0, 0. There's no transformations there. P is equal to 1/2, which means the focus will be up here at 0, 1/2. The directrix will be down here at y equals -1/2. And then I just draw my parabola. And I'm good to go. And again, you could just as easily solve this for y. You get y equals x squared over 2, which is a parabola centered at the origin. And the 1/2 means it's a little bit flatter than a regular parabola, which is exactly what I got. So that's good. We can, though, expand on these basic parabolas here. All of you know that if this is negative, or if this is negative, then the parabola is going to open downwards. But we can also make them go side to side. Essentially, you get the exact same equation, but instead of having x squared, you have y squared equals 4px. That's a parabola that opens to the right. But then if p is negative, if p is less than 0, then you'll get a parabola that opens to the left. These are not functions, but the conic sections we're looking at are not functions, so that doesn't really matter. The principle is always the same. Whatever is squared, the x or the y, solve for that. And then once you have your coefficient set it equal to 4p, solve for p. That'll tell you your distance to the focus and the directrix, and it will tell you the direction it opens, based on whether the x is squared or the y is squared, and whether p is positive or negative. Well, we can do all that, but keep in mind, we can also do what you have done before with parabolas. You can move your vertex around. We saw the same thing with ellipses and hyperbolas. Essentially, the only change to the equation is if I say I had this one, I could do x plus h squared equals 4p times y plus k. And now I can just find the shift in my vertex, and I'm good to go. So let's just solve one or two of these out to make sure we understand what's going on. So first, suppose we have that, let's see, my vertex is at 2, 3, and my directrix is equal to the line y equals 5. Find the focus and find the equation. Well, let's see. If I'm going to graph it, let's see. The vertex is at the point 2, 3, so we'll say it's right here. The directrix is y equals 5, which is up here. And then clearly, I can't open in the direction of the directrix, which means my graph has to open this way. And then let's see. To find P, the distance to the focus, it's the same as the distance to the directrix. So, if that's 2, 3, and that's 5, this is the distance 2, so it's a distance 2 to the focus. So that'll be the point 2, 1. Now I have the three things I care about, the vertex, the focus, the directrix. Now I need my equation. It's a parabola opening downwards, which means the x is squared. So we get x squared equals 4py. P is the distance between them. We already said that was 2. So x squared equals 8y. And then there's just one more thing we need. In this case, since it opens downwards, the p actually has to be negative. So stick a negative right out there. Now it opens downwards. Now I have everything set up more or less the way I want. But, well, in this form, this vertex is at 0, 0. I need my vertex at 2, 3, which means I have to shift that vertex around. So I just have to do my transformations. So, let's see. We put some parentheses here. The x shifted 2 to the right. So we always switch signs. So that's x minus 2 squared equals negative 8. The y shifted 3 up. So we do y minus 3. And there we go. We're good to go. If you're a little concerned about this being minus 3 and you get used to always say that the y change always agreeing with what the sign is, meaning if you do y plus 3, you go up 3, y minus 3, you go down 3, just think about actually solving this equation for y like you're used to. You would divide the negative 8, and then you would add the 3, so you would get y equals this square plus 3, which in our old terminology from 171 would mean you go up, which is exactly what we want. If it's in parentheses, you switch the sign. If it's not in parentheses, you don't. Because of the way we're writing them, we have to put them in parentheses, so we do that. The last thing, we have about 2.5 minutes left, so really quickly, let's see. Suppose we have x squared minus 4x. X squared minus 4x minus 8y minus 20 equals 0. I want to identify that really quickly. We talked about ways to determine from an equation like this if you have a hyperbola or an ellipse. In this case, for a parabola, x and y are linear and then only one of them is squared. That tells you it's a parabola. If they're both x and y are both squared, it's going to be an ellipse or a circle or a hyperbola or something. Since only one of them are squared, it's a parabola. So what do? Whatever one is squared, we want to isolate that. So bring all the x terms to one side, everything else to the other side. So we get x squared minus 4x equals 8y plus 20. Well, let's see. Now what do I do? Well, I want to write this as a complete square, so I'm going to complete the square really quickly. All of you know how to do this. So it's x squared minus 4x. Half of 4 is 2. Square that, you get 4, so I add 4. So I add 4 over here, and I get 8y plus 20 and 4, which is 24. Now over here, this becomes x minus 2 squared equals, here, factor out the 8, and you get 8 times y plus 3. Now I have that in the form I want. Now, really quickly, identify the key points. Where's the vertex? Well, let's see. That's x minus 2, so it's positive 2. Y plus 3 gives me negative 3. Then I need to find p. This is my leading coefficient. So I say 8 equals 4p. Divide by 4, and you get p equals 2. P is positive. The x is squared, so it's going to open upwards, and the distance is 2. So the focus will be at the point 2, negative 1. The directrix will be the line y equals negative 5.